possible. Yeah, think about it. Like, I'm not gonna, we'll be here for 10 more minutes. Okay, you got the data in the frequency column. Number 7, did we have any outliers? Number 7, did we have any outliers? We did not. We had no, we didn't. That was the whole point. We made a box plot, but there were no spikes. There were no little dots on the box plot.
Even the far end of
that was just the maximum point. You got to be careful. Thank you for that, by the way. You got to be careful. Every data set has a maximum point and a minimum point. The question is it too big or too small to be considered typical? Our Aegis 10 was not too big, and the 3s were not too small. They were the largest and smallest, but not too big. How did we check? We made a box plot. If a box plot, if you want to get fancy, it's the IQR method, but I like the box plot.
There was a box plot of what?
It's called a modified box plot. And what a modified box plot does, remember the IQR method?
What data did the box plot represent?
It was our data that we got.
Of just our sample.
It was our sample, right? I didn't rerun it on the larger sample of the cumulative, but I guarantee it's not any outliers because it's too smooth and too pretty. Almost too perfect. Moron guy. Almost too perfect. Is that fair, Dina? So basically the idea is we're graphing our data. We're graphing our data, taking a look at our data. Why do we care? We did mention this earlier. Why do we care if there were outliers or not? If we have outliers, where does the average go? Towards the outliers. And what are we forming an interval around? An average. So if we're forming an interval around an average, and the average is artificially moving towards an outlier, do you see how our whole interval could be affected by the presence of 1 or 2 outliers, especially in a small data set of, say, size 16? That could be a problem. That could be a problem. So you want to check those first, especially with one like this, where you're trying to see if we're doing better than guessing. If we're trying to see if we're doing better than guessing, you really want to make sure there aren't any big outliers. Small outliers would be deleterious in the other direction. They'd be pulling it down too small. But you want to make sure that they either are there or aren't there in the beginning anyway, just to make sure they're not pulling your average in a way. Like I said, your data made me really happy because it was just noisy enough, in my opinion, and it showed enough of that bell to not worry about. Why didn't we check for outliers when forming CIs for proportions? This is actually a really interesting question, which we answered about an hour ago, believe it or not. We never checked for outliers. And you go.
The proportions are either they are or they aren't. So outliers aren't.
There's no such thing as an outlier with proportions. It's either here or it's there. It's not how far here or how far there. Remember this discussion we had earlier about, and Dina, you gave me the word, what the T intervals had more of than the Z intervals, and you said detail. I think that's the word you said, didn't you? Descriptive, I said detail. Descriptive. It tells you not only is it here or here, not only is it right or wrong, but also how right or how wrong. And that's what we were measuring in this experiment. We weren't just measuring right or wrong, we were measuring how right and how wrong, compared to 5. Not compared to 0.5, 50%, but how right or how wrong is what we were actually measuring in this particular study. Make sense so far? Coming together. Create the 95% cut. We just did. We just did. It's, well, I forget what it is now. I think it was 5.2. Thank you! So 5.2, call 5.2 to 7.
Do you want it for the whole?
No, do it for just our study. Just do it for our study. So it's 5.2 to
7.3.
7.3. Thank you.
Or 7.4.
7.4, 5.2 to 7.4, call it good. Some people will argue we should round those down to 5 to 7.
Could you say the mean and then plus or minus?
You absolutely could. Yes, you could totally put the mean plus or minus the margin of error. I'm totally fine with that. You'll see articles that do both. They'll give you the entire interval, or they'll do that and make you do the math. Totally fine, they mean the same thing. Excellent question. Cool so far? Okay. Is this confidence interval evidence of the existence of our ability to sense the energy field? Why or why not? Multiple answers for this one. Give me one. Who says yes? And here's why?
Statistically, yes, because it's above guessing.
That's a great answer. Statistically, yes. Because statistically, even with the margin of error, we are above 5. Now some people are going to argue, wait, if the 5 should have a margin of error too. Right? Somebody's going to say, 5 should have a margin of error. My counter to that is, that's a parameter. My counter to that is that 5 right there is not a statistic, it's a parameter, it's the binomial distribution, which doesn't have a margin of error. It's got an average. Well, it's got a standard deviation, of course. But the average is 5, or inarguably. If you're guessing your average is 5, there is no margin on guessing. Much the same way that when they start a football game with a coin flip, and somebody flips tails, they go, wait a minute, that's 0.5 plus or minus. No, there's no plus or minus on a coin flip, it's 50-50. You don't account for sampling error. Does that make sense? So, yes, that is a perfectly fine answer. Who says no, it's not evidence? That's good, Scholar, give me your reason as to no.
Well, there's too many extraneous variables.
Love it, doing extraneous variables. It replicated under more stringent controls. I guaranteed 5 is in the tank. Good, write that down. Lauren, go.
We would have to have some sort of definition for statistically significant.
Practical.
Yeah.
Good, good. Do you hear what Lauren just said? We have to have some kind of a definition for practically significantly more. She doesn't believe that 0.2 is practically significantly more enough. I love that answer. I love the answer that we have too many experimental biases, especially the heated hands one. What if everybody that got the 8 and 9 and 10 were suspect to the heated hands argument? Well, then we throw those out and the average comes down, doesn't it? The average then comes down. And I'm not saying heated hands are proper like you're saying, JC. I'm just talking about like the fact that we can feel heat on our hands.
Which is a form of energy.
Of course it is. But is it the energy field or just energy off the heat of our hands? I'm getting into, I don't know a whole lot about that, so I'm getting into like dangerous warfare.
One scientific argument that energy is given off of either heat or light, and since our hands are
Fair enough.
off light,
Fair enough, fair
that's
enough.
the energy.
Do you see how statistics doesn't always answer the questions? It gives you this beautiful, concrete piece of information that you can then create more questions. Okay, so how can we make the study better? Is 0.2 big enough? Well, 0.2 is bigger than 0.0, but is it big enough? Sense of coffee date, sense of coffee date. But that's the whole point. Statistics doesn't prove generally anything. As a matter of fact, there's going to be one time in this, it doesn't. It doesn't prove anything. There's going to be one thing in this class we're going to prove. Next class, we're out of time in this class. There's a thing called proof by contradiction. I'm going to do a little bit of geometry with you guys next time, a little teeny bit, tiny bit. To show you what you guys just figured out for yourselves, I want to tie it back in. Putting that bell curve up there, the perfect bell curve up to our data, was fantastic. Because you got what's called a null distribution and a sampling distribution side by side. And you can actually say to yourself, it looks like our sampling distribution is not with the null distribution. This just certifies it. That just certifies it statistically. But then the fistfights begin. Is it enough? Is it enough? I don't know. Can't answer that. Good? Good. Next time, hypothesis testing. But if you want to get into the T-interval homework and look at that in the quizzes, I think you guys are solid now. If you want to turn these quizzes in for one of your submissions, by all means do. Make a pile of big out here. Okay, dope. Excellent questions today, friends. Excellent. Angie, 10 for 10. Beast. Beast test.